Are you ready to go? We're waiting
I'm
for
ready now.
All right. Do I need to stand over here?
No, I can move the camera. It's
Okay.
portable.
Thanks everybody for coming. We're kicking off the new year. We don't typically do one in January because nobody wants to come back here like right after the holidays. Like we're all still hungover or so kick it off in February. As otherwise, we go the whole year. So we go all the way through December. Thanks for coming. I'm going to kind of just quickly go through the slides and we will kick it off and send it to Eric. So this warning really only applies to the people on the call. The recording is a more focused mic, so it's not quite as much of a warning. We used to do the recording through Meet.
No, we're doing it through Meet now. Yeah, I don't have his mic.
Okay, so this does apply. These little boxes here are really good during the presentation. If you whisper, they're designed to find people in a crowd and let them ask questions to the presenters without having to do that. Whisper at your own peril. If you want to speak here, and you can do that. There's all this kind of official way where you can, like, nobody submitted a paper call. I ought to just take that off. Like, just come find us if you want to speak here. Come find us either after this meet or especially go to the fortutah.tech. That's where you can find the link to join our Slack. And there's a GoLink Slack. Just ask on there, say, I want to speak. Someone will get you to the right place. Really low key. I have a ongoing for about the past 2 years policy that I will let anybody that wants to speak, I will get you a time and a place to speak. Doesn't have to be the whole thing. If you're really nervous and you just want to do like a 15-minute one, we'll find you and a couple other people and do a 15-minute one and do like a group thing. So we are still covering, we got suggestions here, we're still covering the basics. We are going through, on that Forge Slack, there is a Canvas, which is like a Slack built-in wiki. That is all of the standard lib packages. That's all the stuff that just comes with the language that helps you do things beyond just the fundamentals of the language. So we've covered a bunch of those, but there's so much more stuff that just comes with Go that you don't have to download any third-party dependencies. You can build really cool things just with the batteries that are included in the language, and we're trying to get through all of those packages. Eric's going to cover really one of the kind of central ones today, but there's tons more, so you don't have to come with some like crazy new out there thing with Go. That's fine if you have that, but honestly, people love these fundamentals talks, so we're just going to keep powering through those because no matter how long you've been using the language, I mean, I learned something in every single one of these talks, no matter how much I use any of these packages. So, time to speak, we've got, I think, openings pretty much the rest of the year. I don't have next month booked up. I have it kind of wide open. There might be someone pre-booked in like April, but otherwise, we're wide open, and I want to hear people talk more about standard lib. I will always take a second. There is that jobs channel in Slack. There's a place to post if you're looking for a job or if you have some jobs there. It's still got decent activity. So like there's stuff out there. I know we've specifically, I would be remiss since they're paying for our food and giving us building. We're hiring engineers. We've still got people that we're hiring. We're mostly looking for more senior, but if you're a Go developer, go look at the careers page on gearweave.com and come work here. Light plug for our sponsor, but also if you're not a sponsor and just looking for other jobs, that's a great place to look is on that jobs channel in Slack. That's it. I'm not going to spend a lot of time yapping. I'm going to pass it off to Eric, who's returning. This is the second time. We're really glad to have him back. And it's going to talk about what I was surprised. I thought this would be one of the first packages scooped up, which is the FUMPT package, right? Like, if you don't know, FMT, FUMPT, we all kind of just use one thing out of it, or maybe two. But there's a lot of really, really interesting stuff in there. If you dive in, what seems like a simple thing on the surface, it's got a lot of cool stuff behind it. So, take it away, Eric.
Awesome. Thank you.
Got to get you.
All right. Hold up. I think it's interesting about these microphones because I wear hearing aids. I've been wearing hearing aids since I was 3 years old. And the new technology in these hearing aids do the same technology in these microphones. Inform to conversation and try to find out who's talking. Sometimes it doesn't work that well because it's like, say I'm in a crowded lunch cafe and like there's a louder person that's talking in the conversation that I don't care about. It picks up that conversation and I'm just like, come on.
Accidental super spy hearing is what you're saying?
Yeah, right. I can totally work for the FBI or CIA. Rather not right now, so take a pass on that. So So we have to do some quick setup.
I'm gonna get the light since you're.
Yeah.
I'll see. Each easier to see.
Make sure my code is all. Alright. So, yeah, like Carl said, this is my second time presenting. I'm one of those engineers that's trying to fine tune his presentation skills. I've been a Go engineer for about 2.5 years now. And I've been a career developer for about 2.5 years from University of Utah, and I've been working as a Go platform engineer ever since. So I still feel beginner, although I'm kind of transitioning into the point where I shouldn't say that I'm a beginner. But I love Go. And I think, Carson, why people haven't hopped onto the FMT package is because it's like, this package is just kind of like the first package you learn. It does the printing and then you just move on. Not much else to talk about. Luckily what I've discovered is that there's a little bit more to talk about with this package. And so we'll dive into that and hopefully find some cool things and learn about it. So yeah. I am so confused about what we call this package. I've heard FUMPed, I've heard FMT, I've heard format.
It's FUMPed officially from the Go team.
It's officially FUMPed,
It's
okay.
officially FUMPed.
Okay, so my AI lookup of how you pronounce this package is wrong. So thank you for letting me know. I'll try to say FUMPed for the rest of this
You
presentation.
can say whatever you want.
I think,
We don't
reading about
judge.
format.
Words aren't real.
Format is the odd one out to me. Bumped FMT.
Okay, interesting. Yeah, by show of hands, who says FMT? Okay, who says FUMPed? And format for anybody who's crazy enough like me that was calling it until this day. Okay, cool.
David, thank you.
That's exactly my experience too, David.
Clarifies that a lot, David.
Yeah.
He just said FMT, like those letters. We have no idea how he's pronouncing them.
Right. Oh.
Also, FUMPed, F-U-M-P-T, is actually another package that does additional linting and formatting on doc strings additionally. So there is an FUMPT open source package, not part of this talk, but the fact that they stole the pronunciation is kind of a joke. Not a joke on their package, just like an inside joke, I guess.
Fair enough.
You gotta just take the U out of it and pronounce it FUMPed.
Right on. Okay, I won't spend any more on that. Thanks for entertaining that thought. So, what do we say? Bumped? Is it bumped?
It's bumped.
Pick one and go with it. It's fine.
Yeah, bumped. Okay, we're going with that. This is pretty interesting because, like, it's the first package that we touched. Like I said, you know, this is the hello world of Go. You know, you do print line, hello world, and so, you know, this is pretty basic, and it's something that everybody touches, so everybody should have 100% knowledge of this package. There's a little bit more with that. But I'm sure if we look at any repository in Go, you can find this package, which is great, because we can use the knowledge we learned today and apply it to our project, most likely. Now, with FUMPed, there's actually more than just printing. So I want to let people know that right now, is that there's a little bit more than that. So we'll discover that. Wanted to dive into the history a little bit for this package. The Go designers took heavy consideration or inspiration from C's format or printing and scanning functions. And so you'll find similar verbiage, and the function names are similar to that. So if you have experience with C or the I don't know, like the bash scripting kind of after that, then these things will be kind of familiar. Go has certain advantages over C's functions though, that Go can statically vet the format strings. When you give it a format string, it can, the static compiler, I would say, just analyzes and makes sure that you can match a verb with a variable. If you don't know what I mean by that, I'll define that later. And also, Go has like custom interfaces that other packages can define. We'll look into that. And then it's also, the package has much more than just writing to standard out or consuming from standard in. It actually implements the IO writer and reader functions, which we'll also take a look into. So the verbs are, you've probably seen Go format strings. These verbs are basically placeholders in the format print line stuff. You probably mostly use %v. This is the general verb. Take note that %+v will actually label the verb with like the variable name. So they'll say, like if you give it a variable Bob, and it's an int of 5, then they'll say Bob : 5, I believe.
No way.
Yeah.
I've been doing that by hand
Oh, really?
forever. Yeah.
Oh.
I use
well,
percent, I would use the hash v all the time, %v, but I had no idea about +v.
Okay, yeah.
Sin no more.
I will, thank you.
Yeah, and it also prints out like all the labels in the struct as well, like it was in the struct. And it does it recursively, except for pointers. So if you have a struct, if you have a pointer, it'll print out the address. So whatever the value is assigned to the variables. We'll discuss a way that you can get around that. %#v is Go syntax representation. So I tried finding this in like the AST package. I'm sure that they use this in some way for, what's the word? Like making templates and stuff like that. But I couldn't find that. I won't go through this all, but there's specific types for integers, floats, strings. Quickly for integers, this is like digits, I believe, Boolean, hexadecimal representation, and others, which I'll pretend like I know off the top of my head. And %t type value is pretty cool. So,
I want to hop back there for a second.
yeah,
I think is really worth calling out,
okay.
because I see too many people, if you need to quote something, like doing string concatenation to do your quoting, and like not having that all break if you have actual literal quotes inside your strings. So, like I say, really, there's also strings unquote. I think it's just a wrapper around that. So
Right. Yes.
that's a particularly useful one if you aren't aware of it.
And that enables you to not have to do like escaping in the string.
Yeah, it does the escaping for you, right? Like if there's a quote in there, it does that escaping. So
Okay. Cool. Good to know. These are the most common functions in the Opt package. So I lay them out on this table. These are kind of sorted by the prefix. So these functions have a very unique prefix and a very unique suffix. Not unique, a systematized prefix and suffix. So print and scan, these are the plain, whatever's not the prefix and suffix, whatever that word is called, is right to standard out and to consume from standard, to read from standard in. If there's an F in front as a prefix, then you can print to any IO writer and read from any IO reader. So that's the implementation of that interface that I was talking about. And if there's an S in front of the functions, then that's writing or reading from a string. Yeah. You got that right. Okay. Also append, I'll mention append as well. This is kind of unique. and we'll get into why. It appends results into a byte slice. So you give it a byte slice, it does some stuff to it, and then it returns that appended byte slice. There's some performance implications with that. So the suffix, if there's nothing, then it just does default formatting or just no formatting. If there's an F, then the function will take a format string. So that's where you can write your own string and have some verbs in there in the way that you desire. And if there's an ln as a suffix, then that will terminate reading, or it'll add a new line. It'll terminate reading at a new line, and it'll stop scanning when there's a carriage return or new line. Yeah. Width and precision. So say you want to build a table, you want a table that has a column full of integers, so it can be, you know, two digits to 5 digits, and you want the width of the column to be like 10 so that it all is aligned correctly. That's what width does. And precision helps you to have, it reads in only a certain decimal points or precision of whatever you're supplying it. And yeah, so there are also flags, so you can left align things and right align things and zero pad things. I have an example that I'll just pull up. So, oh, it's not dark. This is a table that I made. It's, you know, 10 wide, and there's some precision here. So I have a number that has precision 4 and precision 2. So it's the same number. And you can see here, this is a printf function. So we supply it with the format string, and then the values that are specified as the verbs here. All of these numbers are left aligned. So if we run this, we get a nice pretty table. We can see left aligned values with width 10 and precision 4 and precision 2. It's important to note that these values are not truncated. They will be rounded, as you can see here. So we have 469. It rounds up to 47. So, that's that. Interesting thing about width and precision, if you use the %x verb, so what width and precision does is it counts in runes. So that helps it with the Unicode stuff. But if you print out in hexadecimal, with the %x, it starts counting in bytes. So just be careful with that with Unicode characters. For example, with these emojis, if you run this, refreshing. There we go. So this first line is just printing out the first character of the string. This is printing out the first byte of hexadecimal. So rather than printing out the whole value for this happy face, it just did the first byte, which is cool and something to keep in mind. Okay. There's also something cool with width and precision and just argument indexing in general. So if we go back to this example, what the compiler follows is just like the natural order in the string from left to right with these arguments. But you can change the order of those arguments with argument indexing. So you can add brackets around a number, and it'll it'll go from, it'll do a specific argument, if I'm making sense. But you can also insert numbers for width and precision based on these arguments and stuff. So I'm just going to pull up this example because words are just not making sense to me right now. So if we see here, this is the normal order, but you can reverse the order, and it's one index. So it's not 0 index, it's 1 index. So 42 will go here, and hello will go here, rather than 42 and hello.
Does it allow you to like reuse? So you can say like, hello, world, hello, without actually having to send the variable twice.
Yeah, that is a very good use case. It's actually a better use case than I was thinking. I was going into complex things. But, okay, yeah, here's repeat.
Todd has questions.
Yes.
Did you find who made the decision to one index it so we can speed this process up of finding them and destroying them?
Because everything else
Probably
would go as
referencing
0
something,
index.
right?
0 is the format string.
Did Lua get in here somehow? I don't understand.
Oh, I don't know. It is atrocious, for sure.
I do like the argument that 0 is those refer to arguments to print F. So 0 would be the format string itself.
Probably.
Can you actually do that? Can you put
I don't know if you can refer to it, but I just, for counting purposes.
happens if you
Wouldn't that just go recursive?
Yeah.
put 0 in there and see what happens?
Yeah. I wonder if
I know that's not what you were saying, but now I'm really curious.
It's illegal.
that'll probably infinitely loop.
Yeah, that's a good point.
It won't fill it back in, it would just treat it as a string, but,
Yeah, that was interesting to know. So it makes sense that the argument 0 is probably just the.
Making sense.
Uh,
Because the way they're treating it the same way you treat OS args, which index, no?
It is 0, it's just 0 is the command itself.
0 is
not
the command itself, so I guess
Printf is a system.
so I guess one does make sense, I'm good. Todd still wants to
It
kill
is what it is.
Yes. We're all safe. We don't have to burn down any buildings. It is 0 index, just don't.
Find the reasoning.
Sure. Reasoning, yeah.
Yeah. Now this right now, so I can.
You could just build a linter or something to like change the indexes for you.
Just obfuscate it in your VS Code.
I'm gonna fork Go now.
Yeah. Cool. This example is what I was talking about with inserting width and precision. So you can actually dynamically specify your width and precision and insert it into here. And then this is the value right here. So we'll see that. So this translates to 12.4, which is 12 width and 4 precision.
This brings up one of my earlier questions. So with that width, right, you had it at 10 before. What happens if the string that I give it is longer than 10 characters? Is it cut off or?
For width,
Yeah.
I don't think, well, let's see. I don't think it is, but precision, if you apply precision to a string, what precision actually does is it only reads in the certain amount of runes that you've given it. So if you've given a string that's more than the precision that you've asked, then it'll only, like if you have a string of length 6, but you have precision 4, it'll only read the first 4 things of the string. So if you want to enforce that width, then you will want to add that precision part for string.
I see.
Yeah.
So I'm just trying to link that back to like, why would you want to supply width dynamically? And the one that makes sense to me is you want things to be aligned, but you want them to be aligned to the largest item in a particular column, right? So you go like, what's the biggest name on my list? Well, the name column's got to have this thing I can only know after I've got all the data, put it in a variable and passed it into my print.
Just find longest name and then add that into, okay.
That's how I see this. I mean, you tell me if you thought I'm not a use case, but that's what I see that used for.
I think that is totally valid, and I wish I had thought of that. But I'm glad that, yeah, if you guys have like use cases or something, please feel free to speak up. And the thing that I thought of was with the argument indexing, to have localization. So we can see here, like, this is hello world, welcome to 2026. But if you do a different language, then you can kind of switch around where, because like different languages can do their subject and predicate and things in different orders. So if I run this, you can see, I can't read this language.
Willkommen in Jahr 2026, and you also have English world instead of German Welt.
I'm sorry?
Willkommen in Jahr 2026, where it's 5,000 something.
You've got to translate the word world.
Okay. Yes. I probably have it wrong.
That's a really interesting use
Point,
case.
right?
That's intriguing, the way you've used it.
Yeah. So, that's that. So I'm gonna run through some of these interfaces. These are the interfaces. I'm gonna talk about them in more detail. The most basic interface is the stringer interface. So if you apply printf to, let's say, a custom struct or something that you have, you can kind of style it however you want. I'll run this one real quick. You have a representation of an animal with a name and an age, and you can print it. You can see right here, we only did format the print line. There's no fancy things that we did, which is kind of cool. So you don't have to mess with format strings. You can just kind of, well, you do, but you can just define it once, and then
You delegate that to the person, whoever owns the thing you're printing, not the person happening to do the printing, right?
correct, yeah. So this is the implemented interface right here. GoStringer is this %#v. And this is where I was trying to find the AST package, because I swear they probably use this. But what else you can do is that if you have like a social security number or some sensitive info that you don't want people to print, you can just kind of like omit that field. Or, as I was talking about, pointers, when you do %v or %+v, will print out the address of the pointer. But if you want to drill down to that pointer, then you can implement the interface and apply it yourself. I see a hand in the back.
Yeah, I was just gonna say that we actually do this at Weave, we have a config file that we use to run our CLI tool. Bart, if you guys have heard us talk about that. And there are some sensitive tokens in there, so we have some printing logic that basically says exactly this. Redact tokens when you try and print out your config unless you explicitly say that you wanna see them.
Cool. Yeah, good to know.
This one's hooked in when you use %v, or the other one is hooked in when you use %v, this is hooked in when you use %#v.
Yeah, but the principle applies to %v as well. I just was like, oh yeah, I should mention this. So, yeah, it applies to both stringer and GoStringer. You can do this like omitting or drilling down to the pointer stuff. So here I've implemented GoString, and you can see, since it's a GoString, I did it in the format of what a GoStringer would be. And I specify the name, age, addr city, state, and I also did my nil checks. So, and if it's not there, then I just won't mention the address. And we omitted the social security field. So here we define the person, and we just do that %+v. Calls GoStringer, which we've defined and handed off, and that does the work. So if I run this, you can see the address is printed, it's omitted the address, and we can't see the social security number at all.
What was that second print? Sorry, you had some comments there, you scrolled past it real quick.
Oh. Sorry, about this person without the address? Yeah, it's just, doesn't have the pointer initialized.
I see.
Yeah, it just went to this second line.
I got you, that's,
A little bit harder to get the context when you have a long code and, yeah. All right, so you can actually implement your own formatter. So if you have a type that you want to format, you can. So the format gives you a state interface, which allows you to write to a byte buffer, I believe. You can take into account the width and precision that the formatter needs to take into account, or you can just ignore it, and the flag. So I will show you my example, which is temperature. So I will show the examples first. So we have a temperature, and we've given it the temperature in Celsius. And here we've defined a custom verb where Celsius, Fahrenheit, Kelvin, and kind of be precise on what we want to print out that temperature.
This is like the coolest thing. How did I not know this exists?
Yeah, it's pretty awesome.
Here, my mind is blown.
Yeah, so here we can see we've done width and precision, and this will also show in the zero padding as well. I'll run this real quick.
Because how many people have a use case for doing terminal facing, like specific, like most of the time we spend doing pretty formatting on string goes to some kind of web UI. We don't do a whole lot of UI development in Go's ecosystem, which is terminal based, right? Like,
Yeah, but this is still, there's
no,
so many
I'm not
times where
saying
like,
it's not cool. I'm saying the reason you've never run across this is because you probably have never needed pretty formatting.
I think I have needed, and I just did it the hard way.
Oh.
Like helper functions, right? Because without this, what do? You write a function that's like, format temperature to Kelvin, and then it returns a string, and you put that string into the sort of like, this is so much more flexible.
Right, then you don't have those nested functions stuff.
Yeah.
Brendan?
Maybe you're gonna cover this, but is this how the funct error, like W parameter works, where you can wrap an error using the funct package? Have you
We
seen that?
probably do that internally. Yes, I will come across that, but remind me to look into that when we come to that slide.
Cool,
We
yeah.
can check the source code and see if they implement this internally. Yeah. But with these interfaces, it's funny because like the fun package just does this pattern internally with their own struct. Let's see, so I'm gonna dive into what format function we have right here. So we have the width and precision that we've taken from the state. We check for flags, and then set a default precision. We define Celsius and Fahrenheit, and then we just have a switch statement on the verb, which came from the function or the interface. So we can see it does Celsius by default with that V verb, and then Fahrenheit, obviously. Kelvin, you add 273.15. And then this is sort of like FUMP's error language. I didn't have a slide for this, but I'm going to come across it really quick. So if you kind of have something that's bad or something that the format string cannot interpret, it'll return this kind of error in the logs or wherever. So yeah, that's all I'm going to say about that.
Does that like show up in its printed string, or is it just a standard error? Where does that go?
I'm assuming it'll show up, so it'll show up wherever it prints to, right? So we have the functions print to standard out, standard, or like IO writer. So I think it just shoves whatever it was supposed to put, it just puts that error statement over to that. Sorry, I'm looking over here, but it's probably,
No, it was me over here.
oh, cool.
Yeah, I've seen almost all of these just in places if you mess that up and you ignore the lint warnings, like these.
Yeah, right.
They just end up wherever it was gonna go.
Awesome.
And to clarify, sorry, just one more, you just have to implement that format interface on anything.
Good, yeah.
And then that thing suddenly supports any sort of, verb that you
Yeah.
can imagine.
Right, yeah, you have to like define the cases for the verbs, but like, it's just one and done, and then you don't have like
And you don't,
print line and then like a bunch of formatting methods nested into it, so.
helper functions or anything else, and you don't have to like register them with the format package or anything, it just says, I'm about to print this. Let's see if it has ideas about how it should be printed, including full-on custom formatting.
Yeah, and this goes for
That's so cool.
formatting output, formatting strings, remember that, formatting any IO writer. And this also goes, I think we'll talk about like inputs as well, you can do some fancy stuff when scanning. So here, I'll just breeze through this last part, I can send this to anybody. Reply written precision ourselves, so it's a little bit manual and cumbersome, but it's actual code, a lot more simple than that. Right here, just format the printf. Station. Oh, so if you want to look at an official implementation of this, go to Go source code and the math big package. The ints and floats do this custom formatting. So you can see it's looking for the room, the verb, and just does a bunch of stuff because, you know, these are big numbers that you have to do a little bit more to. For the sake of time, I'm not going to dive deep into it, but Scanner does something similar. So now we're going to scanning, which is string input, IO reader, standard in. It has a scan state and the verb. So I just did an XY, it's a point function, and it can read an X and a Y. So it knows my scanner knows to expect the opening parentheses, a number, a comma, a number, and a closing parentheses, and to put that into a point. So here, scanning the point, the input. So looking into here, here we don't care about verbs, we just have a specific layout. So we are reading a room, see if it's the open parentheses, and then we go into here and we call skip space. So this is the white space ignore. So this allows us to kind of not care how much white space there is, just like read the next non-space character. I don't know the behavior if it's scan line. If you have it on multiple lines, scan line will probably exit if you have the point on multiple lines. So yeah, run this real quick and we can actually, so that all worked. And let's just for the, we can experiment with that later. I don't think I have scan line, and this have characters. Probably in there. Error unexpected new line. So that should be in a more official FUMP error. There you can see. Yeah, that's also my logic needs to be.
So again, I think you're pointing out, I'm just keep talking. They keep pointing out me doing all the things the hard way instead of using FUMP. Like, there are a lot of functions that I've written that take strings, chop the strings up, put pieces of that strings in certain ways into some new struct and return that struct. And I've written those functions. And then you call, like user from string or whatever.
Right.
And it's kind of nice, but like you're saying, I'm looking at this like, man, I could just be like writing a scan interface, getting the utility interface, getting something much more readable of just like scan in a user from a string. And it's sort of the same thing as the helper function, but in a way that doesn't like bloat with more names of things, right? It's just like, I don't know, just scan everything in from a string. It knows how to do that.
Yeah, it gives more of the work to the pump package rather than you having to do it.
Yeah, that's, I don't have to learn what everybody's name of all that helper function is to read from a string into the thing. They all just literally just everybody write their scan function and that's just really another use case where I've been doing things the hard way.
Cool.
I thought I knew this package, I don't know nothing.
Carson's having a revelatory moment.
I am.
Let's see, I'm gonna rush through, I know I'm coming up on time, so, this is important. There's a priority and kind of like a check for what Font does when it prints. So it does reflection first, and then it does the format, enter, and stringer, interfaces. That's all I'm gonna say about that. So Font uses reflection, which is slow from what I've heard. So there's some things to help with performance in high performance necessary situations. Font appendef, just you give it a byte array and it returns the appended byte array. But it can do the formatting and everything that we've talked about. So here is a string builder with sprintf with the format string, and then the appendef with a buff array that's pre-allocated, so it's nice and performant. If you run these with Go Bench, Go Test Bench, you can see that there's less or much fewer allocations in memory that has to be done when you use it. So if you care about that, look into appendef. If you're trying to convert a number into string, yes, don't use sprintf, use string converge or convert string com. Yeah, I2A. This is much more performant because it won't go through the step of reflection. Yeah, I think I have results on that too. Much more faster, fewer operations.
I actually made that exact argument on a merge request one time, and I ran that exact benchmark because they're like, I don't think it makes that big of a difference. I'm like, I mean, it's up to you, but here's the benchmark. And they're like, okay, I actually do agree with that. And they changed to strcom instead of format.
Yeah, so that's pretty cool.
But one needs reflection and the other doesn't, right? So that's the main difference.
You're right, I do say format.
I2A doesn't need a reflection, right? Because the thumb stuff is all taking innies.
Yes.
To know what anything is, you gotta reflect on it.
Yeah.
Whereas the I2A like already knows it's an integer, so you take a whole operation off the table every time.
Exactly, yeah.
Wait, so was the append one faster than the string builder?
Yeah, because it
Well,
works
why
on a
did I do
byte
my
size.
talk on a string builder? Because I literally talked about appending as a reason to use string builder.
You chose poorly.
You still use string builder. The main difference is that when if you're going in there, every time you do that fumped and you get a string back, you're getting a new string that's getting put into garbage collection. Like you're building a new string every single time that then has to be like collected and thrown away, which is all those extra operations is those new strings being made all the time. The fumped is just a way of like just building a big string by keeping the underlying bytes and not always making new strings every time. So do use string builder. String builder is great, but if you are gonna like take the results of your functs and then put them into, you could combine it with the string builder there, and it would still be faster.
Yeah, that's true.
It's probably a thing most of us never. It's one of those things. The appendef is probably none of us have any real case to ever use unless you are really in a very specific space. I will not stand here and let anyone badmouth string builder.
I talked about it.
Thanks, everybody.
I don't know, given how much you're doing things the hard way, maybe you're not the best advocate.
Fair enough. Do as I say, not as I do.
Okay, so I'll mention format string. There's a format string function. It's just gonna return whatever the format, or whatever thing it is. So if I, these, this is just what I kind of printed out of like directive equal. This is the results of the format string right here. Is the stuff, not the equals, but stuff.
Can you go back to the code that called that?
Yeah. Oh, I guess I implemented the format and I just called format string on the verb. So, yeah, it takes in the verb and then you can get the format string directive from that.
Okay.
If you were writing this custom format and you wanted to know not the pieces that were parsed out that are in the state, but the original format string that was given to you with the state presumably came from. That seems like a really, really niche need.
And
It's in the package.
Funct error F. So this you can give it a format string and do the %W, like somebody was talking about, where you can, it wraps the errors in however way you want. I've been told that it's been recommended to like use errors join, so it does it in the whatever order it does. I'm not well versed in errors, I should be. You can also add multiple %Ws verbs in there, and it'll just kind of go with wrapping multiple errors. But this implements unwrap as well, so you can kind of disassemble from using error F. I'm not going to repeat myself. These are performance considerations that I just talked about. And I talked about the error output. If you call string on, there's a way that you can kind of recurse strings if you kind of do a sprintf while implementing the stringer interface. So don't do that. Talking about the runes for width and precision. Okay, I want to get to this. So I didn't know about a carriage return thing, % or /r. I've always wondered, like in Homebrew and all those things, like with loading bars, like how did they do that without doing the new line? And it turns out it's %r. So this is what I learned, and this is basically just a loading bar that goes. And so what's happening here is that the carriage return is going to the beginning of the line and writing over what string was there. So that's pretty cool. And I also wanted to mention that in the Go Funct package, they have some really interesting table-driven tests with lots of examples. Like if you're wondering about examples, look at their tests, just because I'm scrolling on. Okay, here, like you can just see all the use cases with pointers, all the other use cases with pointers, expected output. So if you just want like a quick reference of what if I give this input for this verb, look at the Funct unit tests, because they just have, it's very pretty and has lots of stuff. So that's basically it. Feel free to contact me. I'm now an expert on the Funct package more than I ever thought I wanted to be, but now you are too. So thank you, everybody.